So, hello everyone. It's my pleasure to introduce our esteemed speaker today, Dr. Bapan Ghosh. Dr. Ghosh is an associate professor in the Department of Mathematics at IIT Indore, where he has made significant contributions to the field since 2019. Sir has earned his MSc in Applied Mathematics from the University of Bapan and then went on to complete his PhD in Epidemiological Sciences with a robust research portfolio that includes around 35 publications in the international journals. Dr. Ghosh specializes in applied dynamical systems and mathematical ecology. Dr. Ghosh's academic journey has taken him on various research visits to countries like France, Taiwan, Russia, and he has been also honored with various prestigious grants such as Early Career Award, Matrix, and Core Research Grant from SERB, and as well as Indo-French and Indo-Russian projects. In addition to his research academics in nature and society. He is very committed and dedicated to the mentoring of next generation researchers. He has already supervised 2 PhD students and currently guiding 3. Today, Dr. Ghosh will be talking to us on the topic fractional order modeling of ecological and epidemiological systems, ambiguities and challenges. So with these few words, I welcome Dr. Bapan Ghosh and hand over the stage to sir.
Yeah. So thank you.
So you can share your.
Yes, I have to share. Yeah, thank you. So thank you for nice introduction. I'll share my screen now. Files. Is it visible my screen, sir?
Yes, sir.
Okay. Yeah. So thank you, Darshan sir and Hamsi sir, for giving this opportunity to present my recent work. So the title of the talk is Fractional Order Systems of Ecological and Epidemiological System, Ambiguities and Challenges. So here you can see, I'll talk about more on ambiguities and challenges rather than giving the answer to all of them, because I even don't know what to do. So now let's start with my journey to work in fractional order system. So just before COVID, also during COVID days, I have listened some of the lectures. Although I was aware of this fact that okay, some works are going on fractional differential equation last 1 decade, and especially if you see the scenario even in the Indian context, there are several good researchers from our country who contributed a lot in this area. Maybe in terms of ecological system, in terms of epidemiological system, but most importantly, a lot more work done in mathematical point of view and numerical simulation and their solution of fractional order differential equations. So motivated by all those facts and some lectures and all, we started reading few of the papers here and there, and we discussed small things with my students over time. And then last 1.5 years ago, I thought that, okay, of course, one of my students started working on this area a couple of years ago. And but before that also, as I started discussion and all, I started writing one paper, which is rather survey paper rather than one like research article. So it is, of course, very funny often to write a survey paper rather than having many such research in this particular area. But anyway, I started slowly, and it is based on the discussion with my students and other people's, my colleagues here and there. And this is the paper. My all talks is based on this published paper, and the title is the same we have in the talk title. So title of this paper are also exactly same. A little bit changes are there. It's a mistakenly I made some mistake in my main talk presentation. But anyway, this is the paper, and this paper got published in Journal of Analysis this year. Especially, I am very lucky that the paper got online last late evening, and even I didn't have any. They didn't send any soft copy to me. And last night I then sent a message to one of the students at IIT Chennai, and he in a 5-second send the paper to me. So anyway, so this is the paper yeah, it's now online last yesterday. And but meanwhile, this is the starting point of my work. But meanwhile, parallelly, I worked with one of the professors group, Professor Agus Surjayant. He's from Indonesia with his group. And we published one paper here. It's published in Arab Journal of Basic and Applied Sciences in May 2024. And this model tells about the fractional order generalized Richards model. You know the logistic growth model, but this is the more general version. Richards models mean more general version, which is implemented to COVID-19 models with the Indonesian data. So I am one of the co-author in this particular paper. And then in the same time, we also worked, and one of my PhD students, Devdeep, he published last July this paper in nonlinear dynamics. It is the dimensionally homogeneous fractional order Rosenberg-MacArthur model, a new perspective in paradox of enrichment and harvesting. So in this paper, we discussed what possibly can happen compared to the classical Rosenberg-MacArthur models, and some mathematical aspects such as the positivity boundedness are rigorously discussed compared to the other existing literature. We mentioned what are the challenges, what should be the more corrective way to present mathematically the boundedness and positivity, and so on. And I may not have time enough, but I'll show you the modeling part in this talk. Now, this is the so far 3 contribution in this area. I'm not so expert so far. And then the main talk is based on this content. First, now I will discuss about the what is ecology and epidemiology, and then little bit I'll discuss about the different kinds of available derivatives in fractional order, and then I'll talk about the dimension of classical derivative in modeling, and then what is the dimension of capital fractional derivative, and further I'll continue to build different types of dimensionally homogeneous model in Capito framework, and further I'll discuss that what are the still challenges and what caution can be taken and what are the ambiguities in modeling with the Capito fractional differential equation. So these 3 items are based on the Capito derivatives, and the next 2 items are based on the Capito-Fabrizio derivative and Atangana-Bellino derivatives, where I'll talk about whether this derivative really makes some sense in modeling or not. This will be very new, I believe so, and this is here our contribution is. And but there are a lot of I need a feedback as well. Whatever I am claiming really correct or not, so I will wait from the many eminent researcher what is their viewpoint, and then at the end I'll discuss about in this context that why this Capito-Fabrizio and Atangana is not applicable at all, not even partially at all, and why, what are the dangers if you try to model with non-dimensional fractional order systems. So anyway, at this moment, it's not visible, all things whatever I said, but this is my overall scheme. I will move forward. So this is the paper what I already mentioned here. Now, first of all, here, as I mentioned that I'll be talking about the ecological and epidemiological systems. So what is ecology and epidemiology? So you already know many of you, but ecology, population ecology is a very special branch of biological sciences where you can think about the population growth, how the population can grow, or their death, their extinction, or their behavior, even in multi-species environment where you have the many population, how the predation is happening, what are the impact of competition, whether the populations are cooperating with each other, and all such relationship among different trophic levels in system. So this is the things what people investigate in ecology. On the other hand, epidemiology also can be considered as a broader sense of biological science part. But again, someone can think it's more on the medical science part. Of course, we can leave it for, we don't go for debate. But here people explain that, okay, how the disease is spreading in the society and how to control the disease, number of infected people, and so on. And then in both the models, the main estimates are just the population, how to estimate the population, whatever the population size, it may be the number of population, or in ecological system, or even in terms of the epidemiological system, people count the number of infected individual, or sometimes the amount of pesticide you are using in cropping system to eradicate the pest population, or even to control the disease, you need to know the amount of drug, okay? Amount of drug or the time to control a disease. So time is also one such estimate. Also time to eradicate, as I said, that eradicate the pest population from a cropping system and so on. So the major things are that these are the some estimate we need to investigate in such type of system, and those systems are often investigated of the models are developed to investigate such type of estimates or the dynamics of the population using the ordinary differential equation, PD, even stochastic differential equation, and this is the main topic today. I am going to discuss that the fractional order differential equation, of course delay differential equation as well, also graph theory, network theory, and so on. So two important measures in ecology are that population size and the time. Okay, so far whatever I have discussed, it may be the ecology or even maybe the epidemiology, you need the population size. And this population, you see, the population, it can be anything also in general sense. It may be the biological population, it may be the cell population, it may be the chemical population as well. But we restrict ourselves in the biological population at this moment because we will be investigating the ecological and epidemiological models at this moment. And another thing that then the population size is one of them, other one is the time. Okay. So here, how to measure the population size? I said the size. So there are two things, two ways you can measure. One is the number of population. Other one is in terms of biomass. Now, when you use these two, okay. So one is that in ecology generally we use the biomass measure. Okay. So number of kgs, number of metric tons, and so on. Whereas in general in epidemiology, if you see, then we use the count the number of susceptible population, number of infected population. We do not use the terminology that, okay, metric ton per unit area. COVID-19 population is 5 metric ton per unit area. Those terminology doesn't make sense much. Okay, but of course, even in ecology, sometimes we use the number of population as well. For example, in a forest, the number we count the number of lions, not how many kgs lion meats are available, right? However, in ecology, for example, in fishery system, we use of course kg, number of total amount as the metric ton of fish population harvested in a system, so on. But of course, even in on the other hand, in disease modeling, sometimes we say that okay, density of cell as well, even in the disease modeling. So it depends upon the context. So if you see in terms of numbers and units and dimensions and units, then we can see that number, if we count the number of population, then it is a dimensionless. Okay. Whereas if you calculate biomass, then for example, biomass of fish, then it will be in terms of metric ton or kg. For example, this is the one such reference by C.W. Clark. Many of you know who are working in ecological systems that he has a lot of contribution in this area. And here the population are measured in terms of metric ton, in terms of biomass. And their biomass, that is the unit is mass, dimension is mass, and unit can be metric ton, kg, and so on, depending upon the system. Whereas very recently also, the Frank et al., they have studied a lot of models and estimated population in terms of kg. In terms of kg, this is a very recent publication in 2021 using some delay differential equation, and you can see it's the empirical predator prey systems. So the idea here that it depends upon the context what you want to measure and what would be the dimension and corresponding units. So these two things will play a very significant role, whether some estimate of population is a dimensionless or it has certain dimension. Okay. This is the central idea of this talk, and in this talk, I'll discuss about the dimensions and units of different variables and parameters. What I really do not discuss is that I do not discuss about the modeling of any systems. I do not discuss about the dynamics of the system or bifurcation of a particular systems and so on, which is often the expectation of many of the participants. But this is more general topics. So I hope you will enjoy still you will enjoy the lectures. So as I said that I'll be discussing the fractional order system. So many of you might be knowing that there are many kinds of different derivatives, and the oldest one are these three: the Riemann-Liouville derivative and Grunwald-Letnikov derivative. This is more about the discrete fractional order derivatives, and this is the Caputo derivative, which is the most popular one in modeling, and then other two are the relatively popular, especially in the recent time people are using a lot, is the Caputo-Fabrizio, and another one is the Atangana-Baleno Caputo derivative, which is popularly known as the ABC derivatives. There are other few such as the Caputo-Hadamard conformal derivatives, Rage Caputo, and few articles as well discuss about the piecewise fractional order derivatives. That I'm not going to discuss all these, but those are available in many literatures, including you can go through my survey paper, you can get all types of derivatives and their discussions in the modeling. Okay, so here what I want to do, as I said, that I'll be mostly discussing more on the dimensions and their units of different populations, their estimates and so on. So first question is that what is the derivative dimension of classical derivative? So classical derivative means suppose dx dt. This is the classical derivatives. Okay. Now in this classical derivative, let us discuss the most well celebrated model in integer orders, such as the logistic equations. And this equation is very well known to all of you. Now at this moment it will be a little bit funny or maybe very weaker and may not be very interesting at all. But I'll start with the more basic things, that how to derive the derivative of dimension of these derivatives. So before that, you see the meaning of the parameter. Here R is called the intrinsic growth rate. Okay, so intrinsic growth rate is the per capita growth rate, and then K is the carrying capacity of logistic model. So this carrying capacity that is here to say that this X is one species which is growing with some finite resources, and resource is implicit here. Okay, resource is implicit because you cannot see the dynamics of the resource at all. but this K is due to the implicit resource, okay, implicit resource. Now, what are the dimensions and units? So, if we consider it as an ecological model, then T is the time and its dimension is time actually, and units can be second, minute, day, or whatever may be, similar measures. And X and K, they are the population size. As I said, that in general, ecological models, we should consider the biomass as the dimension. So, X should not be dimensionless. It should not be dimensional. It should have the dimension. And this dimension, we are treating it as the mass. Mass is the dimension. And unit is maybe kg, metric tons, and as whatever you think. And then the R is the per capita growth rate. This is actually 1 by time. And that's what its unit will be 1 by second, 1 by minute, and so on. Okay, I just something came in my mind right now that why we consider the biomass in terms of ecology. Even you see that when you have studied in school level, you have seen such type of pyramid, okay, biomass, the pyramid model, where you have the grass level in the very beginning, okay, then you have the next level, next level, next level, and so on. And this is, we say that biomass pyramid. So that is the reason here in the ecological system, generally we count the biomass rather than the number, okay, rather than the number. Now, what is the dimension of dx dt? So this is nothing but you see, the due to the small change in the time, what is the change in the population? So on the top also you have the actually the population. Even you can write this one by definition that x of t plus h minus x of t divided by h, where h tends to 0. So x of t is what? X of t, it is the population. Population minus population. This means on the top you have the population and below you have the h belongs to time. Okay, it's a small time starting from t. So it is actually time. That's what its dimension will be the population dimension by time dimension. And as I said that the population dimension is mass, that's what it will be, mass by time. Okay, mass by time. So that is the reason its dimension is actually mass by time. And what is the dimension of this quantity right hand side function? Its dimension also, you see the dimension of x and dimension of k, they are actually cancelled out. So this is a dimensionless quantity. So dimension of this one depends upon r into x. But the dimension of x is mass and dimension of r is 1 by time. So that's what it is, mass by time. So the point what I want to highlight is that this model is actually dimensionally homogeneous. Okay, so logistic model, okay, is dimensionally homogeneous and people are using for a long time. So for any model, okay, it must be dimensionally homogeneous at the first step. If it is not the case, then this is not a model at all to apply in any real world system. This is the first, you have to accept it. Now, if this is the case, then all our model in fractional order system must be dimensionally homogeneous. And our intention is to check now whether all models are really dimensionally homogeneous or not as of now. So, first we'll discuss about the Capito derivative. Okay, what is Capito derivative and what is the dimension of the Capito derivative in terms of modeling, especially in terms of ecological and epidemiological model. So this is the one such article where the logistic derivatives, fractional, Capito fractional order derivatives are considered, and this model is studied, okay, by this author very long ago, this paper published, and they have discussed about the solution of the differential equation, no major discussion in terms of ecology and so on. Now, this model, if you see, then the dimension of this right-hand side quantity is exactly the same what we have discussed just now. So the dimension right-hand side is mass by time. The question is that what is the dimension of this quantity? So now it's the question to the audience. If anyone can tell the dimension, what will be the dimension? Anyone? Or you are not? You have to unmute, right? All are muted, so I think they cannot speak. Okay, so it's better.
So they can unmute themselves, sir.
Yes, sir, they can unmute it.
Yes, anyone can tell what is the dimension.
Sir, it should mass by time.
Mass by time. No,
Yes, sir.
no, it should not be mass by time. Okay, something else which people all know, but I still want to listen whether someone wants to tell anything. What is the dimension? Dimension people probably will tell it will be dimension will be, no, it should be mass by time. Okay, for making it dimensionally homogeneous. But just you cannot make yourself satisfied by forcefully making it mass by time. You have to determine whether its dimension is mass by time. Okay, this is a serious mistake made by many people, that they just need to fix it somehow. Why not independently, explicitly? They want to determine. One should determine it. Why it will be fixed? By checking the other quantities or dimension in the model. So anyone can tell that its dimension is mass by time to the power alpha. Anyone accept it? Its dimension is mass by time to the power alpha. If you accept, then how do you calculate it? Have you calculated anyone so far? Do you know anyone know the technique to calculate it? If no, probably it's nobody can answer at this moment. It's fine, but you listen. I didn't see any paper so far. Okay, I may be wrong. Nobody has explored so far what is the dimension of this capital derivative in ecology. So far, no. But they assume that the dimension will be mass by time to the power alpha. Okay, but I will derive it. Now, the people may think at this moment that for ordinary derivative, it is dx dt. So that's what it is mass by time. So in general, in notation wise, if you write, it will be d alpha x d t alpha for fractional order system. That is the reason probably people might think it will be mass by time to the power alpha. If this is the thing, then it is very serious issue. It's very dangerous. Okay, and that is the reason I emphasize that anyone have found any tools so far to determine that dimension will be this or not. Because so far I didn't find, but I do not claim it at this moment. But still I will tell probably we are the first to derive this, and we will accept your comments, opinion if you found any such other way to calculate this one in the literature in the future. So let us discuss this part first, how to derive the dimension of this one. So before that, let us think what is the derivative, capital derivative. Okay, what is the capital derivative? So capital derivative is defined in this form, where you can see the derivative itself is there. This is dx dt. Okay, but again you have some kernel here. This is t minus s whole to the power alpha, and we are taking the integration of this whole thing. This is your capital derivative. This is the definition of the capital derivative. Now, what is the dimension of this derivative? So, as I said, for dx dt, okay, dx dt, one can visualize it as x of t plus h minus x of t by h in this way. Similarly, this quantity will be dimension of this whole quantity. In the same way, we use the same simple technique only. There is nothing very innovative. The dimension of this one will be equal to the dimension of this right hand side quantity. Now the question that how to understand the dimension of the expression, because expression itself is in term of integration, but it is not so difficult. Okay, now understand that you have an area. You want to calculate the area, okay, of this region. What do? You will take the small area whose length and width is delta y and delta x. So what is the elementary area? It is delta x into delta y. What is the total area? You take the double integration over the region R, okay, over the region R, and you will get the area. Now, what is the dimension of the area? Dimension of the area is length square. How do you get the dimension of this one? So the dimension is basically this integrand. This is very crucial point, okay, for beginner, at least for beginner. This is the dimension. So the dimension of the area will be the dimension of delta x into delta y. Nothing very innovative. It's just simple thought processes. Now, the dimension of this integration will be also the dimension of this quantity. Dimension of this quantity. Okay, ds will be there also. ds will be there also, because earlier also we have taken, in the earlier case, like dx dy for area. It's the same thing. Now, what is the dimension? Forget about the integration now. Just you have this algebraic equation, maybe not algebraic, but anyway, this equation. No integration is required to understand. Now, what is the dimension? Understand that dimension of this and dimension of ds, it will be cancelled out. Okay. Now, dimension of dx is nothing but the mass. Dimension of ds. Now, you are left with the dimension of t minus s whole to the power alpha. Now, what is the dimension of t? Dimension of t is time. And what is the dimension of s? S also runs from 0 to t. You see in the integration, it is a ds. Integration is ds. So dimension is actually nothing but, my point is that s belongs to in the time interval. In the time interval. S belongs to in the time interval. That's what dimension of s is also time. So time minus time means actually the overall dimension t minus s will be time only. But you have whole to the power alpha. That is the reason it will be t to the power alpha. It will be t to the power alpha. So this is so far we believe that this is very good information. So far we mentioned in this survey paper for the first time, possibly, but again, I do not claim, I should not claim, because there may be some other things. Now, one may think that without thinking, as I said, in such much critical way, it is nothing but, as I said before, that one can think, oh, d power x, d power t power alpha, that it is coming automatically m by t power alpha. But you'll see the climax soon, okay? Remember that this is a notation. One can give notation in many other ways. It doesn't tell you anything at all, okay? Now, this is what as I said that if you come across any such information how to derive, please let me know, even after 10 years. So now what is the dimension of the capital derivative? As I mentioned, that it comes like that, and finally it will be actually, dimension will be in this way, mass by time to the power alpha. Okay. So if you think in this way, then this is our contribution we felt so far. Then if you see in this way, then the previous model is not dimensionally consistent. Whatever I just discussed in the logistic model. because right hand side your dimension is mass by time, and left hand side it is mass by T to the power alpha. So it is not dimensionally consistent. Now, if it is not dimensionally consistent, then one should not use for any modeling. That's for sure. That's for sure. Never use. You should not use at all. Okay. Now, the point is that how to make a model dimensionally homogeneous. But again, I must admit that the previous model, they didn't discuss much about the ecology. They have discussed about their stability and the solution of such type of differential equation and so on, how to derive the solution using some Laplace transform and etc. So how to make a model dimensionally homogeneous? Okay. So there are two methods so far I have found, and we have segregated into two different parts. One is the method 1, we are giving name method 1, other one is the method 2. Although they don't have any specific name so far perhaps, but we wrote that with the others and all. So I'll discuss about the method 1, and this method 1 possibly used for the first time by Ghosh, okay, in a mechanical oscillator system. And I'll show the model now. This is the model. You know the harmonic oscillator or damped oscillator system. So this is, you can see it's a damped oscillator. Okay. So if you think alpha equal to 1, this alpha is the order. So if you think alpha equal to 1, then this will be simply a damped oscillator system. It will be like D2, dt2, some. This M is actually mass. Okay. Mass plus beta damping parameters, and then dx dt plus kx equal to 0. This is exactly the system. What they have done, they have considered this model in the fractional order modeling framework, and they have written 2 alpha. Again, this is actually a notation. Okay. So this is a notation. It's a Caputo fractional order derivative. Now, as I said, that if you use this type of derivative, then there will be problem with the dimension. So to adjust the dimension, what they have done, they have multiplied by a time fractional parameter. It is actually sigma square 1 by 2 by 1 minus alpha in this way, and since this is the d alpha dt, so its alpha is 0 less than alpha less than 1 in this way. So that's what here they have used, just sigma to the power 1 minus alpha. Okay, so this is the one such very earlier work where they realize that a model should be dimensionally homogeneous. Now in this context, if you really want to make your logistic model dimensionally homogeneous, then you have to multiply this factor. You have to multiply this factor. So those models I have written by myself. I just try to give the most simplest model to make you understand. So here you can see this sigma is time. Its dimension is time. So that's what the left hand side, its dimension will be 1 by t to the power 1 minus alpha. But from here you already have mass by t to the power alpha. That's what finally you will be getting mass by t to the power t, mass by t. Now the model is dimensionally homogeneous. Okay, so this is the one such method people have used, and here rather you can see that Professor Bellino is one of the big names, including Professor Nioto from France. They used this type of modeling framework. So here you can see they use this scaling factor to make the model dimensionally homogeneous. Okay. This is also not very too old paper. Okay. Now the next model by another, of course, it's the Indian as well as some other professor like the Professor K.S. Nasir. Many of you may know he published a lot. Also, Professor Balino and his one PJ that seeing one students of Professor Sachin Kumar, Professor Sachin Kumar from Central University Punjab. So they published this paper and they really made the system dimensionally homogeneous in the same way. But yes, yeah. So in this case also they have written actually sigma minus alpha, where probably they assume that this quantity is its dimension is 1 by time, so the things will be settled at the end, no problem at all. So this is the contribution by many in the recent time to make the model dimensionally homogeneous. Now there is method 2 now, and this method 2 possibly used for the first time by Deitlem in his earlier paper way back in 2013 when he discussed about the dynamics of a dengue fever model. This paper published in Nonlinear Dynamics, and he really realized that there is a need to make a model more realistic. The model should be dimensionally homogeneous, and he wrote this statement as well in his paper. And this is the model. Here you can see that in this model, what he has done, that this parameter, it's actually time-dependent parameter. Its dimension depends upon only time. And one more thing again here to mention, that these are the susceptible population, infected population, and in disease modeling, the population is measured in terms of number. And once if you use the population measures in terms of number, then it is dimensionless. However, the overall derivatives will be 1 by time. Its dimension will be 1 by t. T means time actually. Okay, t means time. Now, right-hand side parameter also has to be in term of 1 by time. But if you see, so in the classical model, actually 1 by time, but since it is a capital derivative, it will be 1 by time to the power alpha. Now, if you think this is actually whole to the power h alpha, alpha h means actually the alpha actually. Okay, alpha h means alpha. So this is the order of the parameters they have defined like that. So if you see the classical model, then this mu h whole to the, it was only mu h. Okay, so the parameter, its dimension was 1 by time. Now they are adjusting by mu to the power mu h whole to the power alpha h. That means its dimension will be actually 1 by t to the power alpha. So this dimension and this dimension are matching. So this is the one such way to make a model possibly dimensionally homogeneous. Of course, not possibly. The model is dimensionally homogeneous, of course. There is no doubt at all. But there are something else also you can see. The beta 8, it is not, the power is not taken because they are a dimensionless quantity. That's why they didn't consider any power on that. Okay. So that issue I'll come later also. Now, in this method too, if you really want that your model has to be dimensionally homogeneous, then you can see that you can write r to the power alpha only. Instead of multiplying the time scaling in the left hand side, one can write r to the power alpha. But now you may still think that, okay, what can happen that if one can write whole to the power alpha also, then nothing will happen actually, it will be the same. Okay, or instead of this one is ecological, instead of ecological model, if it is epidemiological model, then dimension of x is number, so it doesn't have dimension. And now forcefully one can write also that, okay, I want to write it is k to the power alpha. Then also the model will still remain dimensionally homogeneous. Okay. Now these are the challenges and ambiguities, that what should be the proper way. Is there any proper way to adjust the parameters and all. Those are still ambiguities are there in the literature. Now, those many such things are discussed in my main paper, survey paper. You can go through. The whole contents are from the papers only. So that I'll not discuss at this moment more. So let's move forward. Here I must admit this is one such very good paper who in ecological modeling, especially in ecological modeling, there are very less paper compared to the epidemiological modeling. And if you see in the last 4-5 years, especially starting from the COVID-19, there are a lot of interest to work on the epidemiological model rather than the ecological model. And people maybe think that it is much appreciated. Of course it is. And there is nothing much in the ecological system, so we can move forward for the epidemiological system. Again, people might have ambition and that okay, if we do something in the epidemiological model, it will be the great work for the society immediately. That's very good idea. Of course, one should go ahead. So the point what I want to highlight here is that there are a lot of papers in epidemiological model rather than the ecological model. And then this is the one such good ecological model paper who realized the need of dimension issues to be addressed. So that's what they have written R to the power alpha, M to the power alpha, and so on. So I really value this type of paper. And this is by Professor Panigar from Indonesia, who is also the collaborator of Professor Agus Surjayant and all, with whom I have a paper. Now, here a few things to mention that one might ask questions further that why this A doesn't have A to the power alpha as well. Even in this particular paper, with due respect to the authors, I would say that sometimes the author finally mentions R to the power alpha as simply R. They just redefine the parameters. But you see, when you redefine, then again, if you calculate the Jacobian and trying to find the bifurcation and stability with respect to alpha, varying alpha, then the impact of alpha in the equilibrium and stability will be lost. So one should be very cautious in this. This is what I mentioned in my conclusion also, that what caution should be taken when people will work with the such type of modeling framework to model the dimensionally homogeneous model using method 2. So you can see such type of model, and this is our recent paper, as I said here, that this is another paper where recently published. This is the classical model, the Rosenwing-MacArthur model. Even you may forget about the harvesting part. So this model is written slightly different way compared to the previous paper. Here we have written 1 plus AB, and here it is A. So A is the capture rate and B is the handling time. So here the problem happens with the time in the fractional order system because T to the power alpha will come. So that is the reason our approach is more explicit, that these are the actually dimensions and all which you are now aware of. Okay, one good thing that here, let us discuss a bit more, that this quantity is dimensionless and this quantity has to be dimensionless, and it is the case. Okay, so the point here is that this quantity, dimension of this quantity will be mass by time. Okay, now what is the dimension of A? What would be the dimension of A? Dimension of A, it will be actually 1 by time, mass into time. Then only everything will match. Okay, mass by time. Okay, mass by time. Now, if we write as before that it is A to the power alpha x y in this way by 1 plus ABX, then this model won't be dimensionally homogeneous in ecological sense, because the dimension in the fractional order system, in case of fractional order system, if we write in this way, then the left hand side dimension will be, derivative dimension will be mass by T to the power alpha, But right hand side dimension, you can see here that here the dimension of whole this quantity will be what? Whole to the power alpha. This means 1 by m to the power alpha t to the power alpha into m into m. One m is for x, other one is m for y. Now here actually there will be a problem, okay, with the dimension, okay, because we need only 1m, but here you have 1m, but additionally you have m by m to the power by 1 by m to the power alpha. So that's what this way arbitrarily if you adjust a parameter in the fractional order system, it will go wrong. So we just played with the parameter which is actually whose dimension is time dependent. Okay, dimension is time dependent. Again, at this moment, I must admit that again this is the adjustment only. There is no mechanistic derivation of such type of models so far. And this is another challenge, that if one can derive such models ecological from a mechanistic point of view, but just not by including or incorporating a parameters. Okay, so that's what in one of my posts I mentioned, that such models, okay, it is one such attempt, but there is no such unique models. Okay, no such unique models. So that is the scope one can think of. So I mentioned it as one of the challenge in my review paper. Now I do not discuss about the results you have here and all, or whether these results are really applicable in ecological system. I never emphasize or claim, but it's gives some dynamics, mathematical and computational point of view one may find interesting. Now, such ambiguities and caution challenges already I have mentioned, but again I'll go through little bit. So the key point is that many researchers didn't pay attention on dimension, but they worked in the fractional order system. Whatever the paper I have mentioned here, most of them having some adjustment of the parameters. They are really dimensionally homogeneous. But even when I started my work 2 years ago, and prior papers a lot, they didn't have. That made me motivated actually to write such type of papers, incorporating many such issues, which possibly be useful for the upcoming researcher. It's not about just to tell the criticism, or it's not about criticizing the other papers. We give value to the other paper and researcher because of their contribution, we are here, and lot of contribution done in this area so far. And it will continue, I believe strongly. So these are the things where the papers not paid attention in dimensional aspect. Secondly, that as I mentioned in method 2, all parameters one cannot adjust by taking the power of alpha and so on. One has to take more precise measures. There are some other things that, as I mentioned, that sometimes after adjusting the parameters, you are thinking that r to the power alpha or a to the power alpha, they are precisely a constant. So make them again fixed by taking another r and another a. That may give some misleading information in terms of ecological estimates, or in terms of finding the proper bifurcation in terms of alpha and so on. Few papers they attempt such type of methodology implemented, but something may go wrong also in their paper. So my suggestion that be careful in these situations. There are more challenges that which method will be better, because there are two kinds of methods. Now to tell you that in one model, you have actually 1 by sigma to the power alpha into d alpha x. In short, I am writing in r x into 1 minus x by k. This is the logistic model. In another situation, it was actually d alpha x is r to the power alpha x into 1 minus x by k. Now note that in this case, the equilibrium value is nothing but the equilibrium of the classical model. Okay, so your x star will be actually k. Yeah, but here also, of course, I must admit it will be also x star equal to k. But if you see the n-dimensional system, here I am not able to explain because these models are very simple. But if you see the previous model, even my model, if you see, okay, let's discuss about more older model. Even here, if you make this is equal to 0, this is equal to 0, then your equilibrium will be function of alpha. Okay, so the equilibrium value in these two models are completely different. Now, if it is some specific particular model, then your answer should be unique. Your estimate of the population, number of population or amount of the population, it should be unique. It should not be too different at all because you are studying a particular phenomenon. Okay, now if I model in one way and if you model in different way, then how to make the models, how do you validate the models in terms of real data? This is impossible to happen. So there are a lot of ambiguity still. Which model is better between these two? But there may be many more other methods people are adapting. I am not aware much. Now, another issue that using the method 2, can you make simple Lotka-Volterra model dimensionally homogeneous? Simple Lotka-Volterra model. So if you see the actual Lotka-Volterra model, then this alpha is not there. Okay. So one may think that okay, just arbitrarily we can write r to the power alpha and model will be dimensionally homogeneous because other people are also doing the same. So I can do like that. Then the point there is that if x and y they are measured in terms of number, then you are successful somehow. But if it is not measured in terms of number, because most of the time in ecological system it is measured in terms of biomass. Okay. Then if you think in terms of biomass, then in the previous model, in RM model, what I said that here the dimension will be actually, its dimension will be mass by mass to the power alpha into time. Whereas left hand side its dimension will be mass by t to the power alpha. Oh, here t to the power alpha. Sorry, t to the. So there is an inconsistency. They are not the same. They are not the same. They are not the same. So the method 2 will not work here again. Then what can be the new model? That is also point of discussion, whether one can think or not. Secondly, you can observe that here I have mentioned only b, not b to the power alpha. Okay. So there is a question, even if you write b to the power alpha, it will work, but whether we should do or not, because once you write b to the power alpha as well, then equilibrium value will change as well. So there are a lot of ambiguity. That's what, as I said before, that I am not talking what could be the answer. Rather, I'll talk about the challenges, the ambiguities, what are the questions one should take care. Okay. So that's fine. Now we'll move to the last two things. One is the dimension of the Capito-Fabrizio derivatives in modeling. So Capito-Fabrizio, this derivative is defined by Capito and Fabrizio in this particular paper in 2015, not very old. And today I have seen its citation in is 3958. Okay, it's a highly cited paper, maybe in the history of fractional order system, most probably. And now the point is that what they have done, that in the fractional order in Capito derivative, the kernel was actually t minus s whole to the power alpha, and there is a singularity. So to avoid singularity, they take different kernel. Okay, and they use this type of kernel here to propose a new model, a new derivative, and this is the derivative. So everything is same like your Capito, but only changes is here. Okay. Now what is the dimension? What is the dimension? So far, I can show you maybe several papers, at least the 10 papers, who have assumed that the dimension will be like in disease modeling especially, it is T to the power alpha. They do not write M because in disease modeling, the number of population is actually dimensionless. That's what T to the power alpha. But I am not agree with at all. So now using the previous techniques, we try to find the dimension of this quantity. Because why not? Because if you find the area in this way and its dimension can be written in terms of this one, then here also it should follow. Here also it should follow. Why not? It should follow. So this is what we have done. And this is our new understanding. Okay. Here you can see what's really happening. What is the dimension now? Okay. So the point here is that if you think this is the quantity, this dimension is well defined. Here you don't have the dimension because dx doesn't have dimension. So dimension solely depends upon this quantity. Now, if you have e power something, how do you find the dimension? You cannot find dimension. E power something, e power time, its dimension is e power time. Does it make sense? No, it doesn't make sense. This is what we observe for the first time. That no, we are not agree with this dimension things, what our people thought of, but that's what, in this sense, this derivative never can be used in any real model. But again, respectfully, all researchers who have discussed, there are so many papers I have mentioned, and I request all the researchers, please pay attention whether you have some other idea to share with. Please, you can do, because I may be wrong at some points, but this is what so far we realize that it never has any dimension and you cannot use in real world problem as of now. Okay, this is the strong information we failed to share. Secondly, that here the Professor Nieto, as I mentioned in one of the other slides, that is from Spain, he also used the Capito-Fabrizio derivative in logistic population models, but he has taken this model, okay, and he didn't discuss about the ecological point of view, but very nicely they have derived the solution of such type of models in simple model. Only one model they have solved, and this published in the Applied Mathematics Letter. And this is the beauty. So mathematically, it is very beautiful to work with those derivatives. But in terms of modeling, it is really doubtful. Now, let's move to the next one. Here is one more model that why I am saying that thinking that everything dx dt to the power alpha, its dimension should not be 1 by t to the power alpha. So that's what actually people arbitrarily think that its dimension will be 1 by t to the power alpha without any mathematical rigorous discussion. And they forcefully tried to attempt that, okay, this model will be using the method 1 by sigma to the power 1 by alpha, and our model become now dimensionally homogeneous. So this is not correct, we believe. Okay, and this is also very recent publication in very good journal, Applied Mathematical Modeling and Numerical Simulation with Application. It's a new journal, but it's growing very nicely. So that is the one such one can think very seriously whether such derivatives and this type of scaling is can be applied here or not. Now further, another model, that is the Atangana-Bellino derivative, Capito derivative. Okay, you know the name, they are the experts in this field worldwide. Whoever will study the fractional or the fractional calculus, their name will come on the first day. And this is the derivative now. And here you can see they have used different type of kernels. It's the same thing like before. This is the kernel, and this kernel is the meta-Glebler kernel, and e power alpha is actually looks like in this way. Okay, so it's actually kinds of t to the power alpha. So this means actually t minus s whole to the power alpha and so on. So you see that its power will be increasing. Now one is the constant thing, then next one will be t, next one will be t squared, next one will be, then the dimension of t is time, then how do you add the dimension 1 by time plus time square plus and so on. So in this way, this derivative also doesn't have any dimension. And there are many, this is also in our understanding, this is the novel. And as of now, if you have such type of transcendental kernel, our theory is that it is not possible to apply. Okay, this is our theory. Now, there are, the first time now, I must admit, before going to the main modeling, that it is one of our paper, and it's published, as I mentioned, by Professor Surjayant and all, me also the co-author. Here also, initially we thought that this is the Richards model actually, and then very recently, one, if someone is interested, one can see the professor that Nyoto studied one Richards fractional order model just 2 days ago. I found the paper published very recently, 2-3 days ago, in the applied mathematical modeling using capital fractional order derivative. Probably that I didn't get the full paper. So they solved such models using Richards model actually. It's more complicated than logistic model, what he has done in applied mathematical mathematics later paper. So the point here is that here is actually ABC model, and here the things is that it is considered that the dimension is 1 by t to the power alpha, and we have actually thought that it will be r to the power alpha, and that's what we have done. Actually, in the classical original model, it was the parameters are r to the power alpha, then we have mentioned r to the power alpha, then this r to the power alpha, we have considered it as r, and then we wrote like that. So in my opinion, at this current situation now, we believe that still this model is not dimensionally homogeneous. I'll discuss with our research group further later time. So this is the one such, but I didn't mention many papers. There are many such papers who assume that 1 by t to the power alpha. That is not correct. You can see the paper I didn't mention, including some Indian researchers as well. But this is the one such things to discuss further. I think these are the all things I wanted to share. Okay, so one can think there is no specific conclusion because I have passed all the information that what are the challenges, like there are different kinds of methodology. There is no unique way to model this type of things. How to derive the order, that is one of our contribution we felt so far. And like if you have ecological model where the parameter adjustment should work all the time, whether in a model all parameters will be adjusted or not. So many more are there in my own survey paper. You can have a look. And one things as of now, one more small topic is there. That some authors, okay, I didn't mention in this presentation, what they did, that they have the classical model, okay, dx equal to suppose f of x and parameter set. What they have done, that they made this model dimensionally homogeneous. That is, the time is non-dimensional. That is, now time become non-dimension somehow. Then they found maybe new model is equal to f of suppose x and some parameters beta or something. And then what they have done, they replace this particular derivative as d power alpha x is equal to f of x comma beta. Okay, so this is one such. Now this model itself is non-dimensional model. Now you can think that okay, I am using ABC model alpha x is equal to f of x comma beta. So there is nothing or nothing to be worried about the dimension, because our main model is dimensionless. Now, my question is that's great. One can go ahead, one can solve finally. So one can get X star here. But my interest will be at the end in terms of biology. What is the quantification in terms of small x star? Because this small x star is my original quantification in terms of dimension. Because dimensionless things is mathematically valid, but again you have to return back to your biology core. So the question is that if you are able to tell what is the X star from there, then you need certain transformation here in terms of the earlier population and new population in terms of the earlier time and current time tau. What is this transformation? What is this transformation? Can you define a mathematical such transformation? This is very serious and very strong mathematical problem, I believe. Okay. Now, if you are able to understand such a transformation, then you will be able to construct one-dimensional fractional order derivative model also. Theoretically, you should do it. You should get back such a fractional order model which has the dimension. If anyone can do, then it will be one of the best research I believe so far, if I am not wrong. But I don't believe, I believe such model does not exist. Final conclusion will be never do dimensionless of classical model and don't work on the non-dimensional model using fractional order framework further. Okay, this is the one such, this is dangerous, this will be misleading things, missing many mathematics and conclusions and sequence. So these are the all such things. So the, now at the end, I must acknowledge that, you see, this is a very long discussion, happened for long times. And once someone write the survey paper, one has to be very expert, should work in the long time. Although I am working for several years, but not in the fractional order modeling. And this is the first attempt, and writing such survey paper is good or not, I don't know. But I must acknowledge that my colleague here at IIT Indore, Professor Anthony Bijas, helped me. We have discussed many such things. And Professor Tarjan Legovic is one of my collaborators earlier times, as well as my recent collaborator, Professor Asif from Indonesia. We have discussed with the dimensions of the harvesting modeling, especially the effort dimension of effort, catchability coefficients, and so on. And also, often times I discussed with Professor Agus, with whom I worked, about the dimension and fractional order modeling. I must acknowledge that contribution. Most importantly, my former postdoc, Dr. Naresh Chandrapati and Dr. Fahim, who is faculty at VIT right now, we have discussed small discussion over time. Also, my former PhD students, Binandita Bormon and my current scholar, Rajni Devdev Zobhans, we discussed very rigorously over time whether things going wrong, right. They helped a lot. That made me more confident that things are still running properly. And this is the paper, as I mentioned, last night it got accepted. Online acceptance done earlier. So you can have a look. And this work I really dedicated to my supervisor. I wrote for the first time. This is the first time I'm really excited that I'm able to dedicate this work to that Professor Tapan Kumar Kaur's 55th birth anniversary. And he's really a gentleman. You may have introduction at certain time earlier or in future. You can realize. And this work is my supervisor. And this is actually the one of the matrix project paper. And so my point that I'm not sure whether people will appreciate this paper, but this is really, I felt something very different. Either people should tell write more comments or more feedbacks, but this should not bypass maybe. I hope that many, including my Indian friends, will read the papers, and I have raised many ambiguities of the other paper as well in the paper, but it's only just to highlight the things so that the future researcher may be aware of. Okay, but I appreciate their and value their earlier all research contribution. And this is one such conference we are organizing in January 14 to 15. So the abstract submission gone, including the registration, is totally closed. It's very packed. We don't have extra schedule much, but still 1-2 students, if really interested, can contact me directly. Okay, there are around more than probably 50 international speakers, and total size maybe 200. It's a relatively smaller conference in terms of number because we have some limitation. We are organizing in one of the best hotel in the city, Indore. So that's what we have some funding issues and all. But still, if you are interested, if you miss, please contact me. Okay. Of course, registration is little higher, the higher side. So that is one such information. Further, there is one such conference you may be interested to attend. It's you can see the complex system modeling. So it's in the same line. It's the joint. They organized by the Christie University. I think their university main campus in Bangalore. Recently, I came to know they have something in Pune as well, and jointly with the Binghamton University, US. So that the main chairperson of the conference from Binghamton University, Professor Hiroki Sama, wrote me personally to help in many ways and join the technical program. Probably this is the first time I might have to spend some significant time for that, but I'll be happy to. And as he requested, I wanted to circulate this message with you. You may attend or think of. This is the thing, and grateful to Professor Bhamsi and Professor Darshan for giving me this opportunity. And thanks to the audience for listening me for a long time. It's 4:21, sorry. And if you have feedback, please tell me, and anytime I'll be very happy to discuss. And I may be wrong at some moments. Please correct things. That's it. Please, if you have some comments. I'm sorry that at what time I lost my means. I crossed my time. Sorry.
No problem, sir.
No problem, sir.
Yeah.
Dr. Darshan, over to you, Dr. Darshan.
Yeah. Thank you, Dr. Ghosh. So it was really wonderful hearing you.
Your volume is little low, sir. Low, Dr. Darshan. Can you be little louder? Yeah.
Yeah, because it is raining here, so I think because of that background sound. So thank you so much, Dr. Ghosh. It was really wonderful hearing you for this inspiring and motivating talk. I'm sure that participants have really enjoyed your presentation. And if any one of you have a quick question, you can ask now.
Yeah, please.
Otherwise,
Good evening, sir.
Yeah, please. Good evening.
Sir, I have some doubt in ordinary differential equation modeling, sir.
What?
Related to dimension only, sir. In ecological model, sir, what is the dimension of species, sir? For example, prey or predator?
Yeah, that's what I said. Suppose in ecological system, it will be mass. Okay, so this mass may be the kg per area or kg per means it can be density also sometimes, right? So kg per unit volume you can think of.
Sir,
for example, if you consider the fish dynamics and the fishery modeling or fish harvesting, then you don't count the number of fish you caught, right? You estimate the total amount, like in term of kg or metric ton. So your dimension of x will be, you can think kg, or in some other situation, laboratory experiment, you can think about the density also. For example, if it is the plant then sometimes we count also, okay, number of plants per unit area. Okay, so it depends, but in general, it will be in term of kg and in term of metric tons. But if it is disease modeling, then generally it is in term of number.
Sir, but in modeling, for example, prey-predator model, we let's say Rosenzweig-MacArthur model.
Yes, yes.
In Rosenzweig-MacArthur model, we use Holing type to functional response. Holing type to
Yes.
functional, Holing actually gave.
Yes, great question. I got your answer now. I have the answer. Your question also I understood. Your point that when the model is derived, it is in term of number, not in term of biomass. Yes, this is a great point of discussion. Very nice. So you see, so people are interchangeably, they are actually using, okay. So the point there, what my view is that if you see the Lotka-Volterra model, okay, Lotka-Volterra model, my screen is visible? Yes? Okay, so
Yes.
you see the Lotka-Volterra model, okay, just imagine Lotka-Volterra model. So it is actually great question actually. I didn't expect this one, but I know the answer. So if you see this model basically, it is actually due to the mass action law, not due to the Holing type 1. Okay, remember.
Yes,
so it is mass action law, and here all these things are having actually mass, like your molecules mass. So this will be in term of density or in term of kg or whatever may be. Understood?
Yes, sir.
I think you agree, because it is derived by Lotka basically. Lotka-Volterra model is due to the Lotka first, then Volterra came into the picture. Okay. So although in the population model they say number, but basically the model is derived based on the mass action law. Correct? Now, even in the chemical reaction, you might have heard that Michelin-Menton type kinetics. Michelin-Menton type kinetics law, it is actually will give you the Holing type 2 functional response.
Yes.
So there it is actually mass, not in term of number. Okay. Now we are actually using whatever we feel suitable. There is no such rule. So sometimes we even don't think whether it is number or it is mass. We just think the dynamics bifurcation happening or not. We don't quantify. So if we don't quantify, sometimes we even write diplomatic way nowadays, population size. Now population size, it is number or biomass, we don't know, leave it. So in that time, you are safer side. Understood? So my view very clear that you can use in term of number or in term of biomass, but you said very nicely that when the model is derived, then it is in term of number, and people now using even the same models for in term of biomass. But I personally feel they are using without knowing maybe, but the model can be derived from mass action law, especially the Michelin-Menton type kinetics. This is my final comments. Possibly you understood what I wanted to say.
Yes, sir. Yes, sir. Yeah. Actually, Holing used mechanistic proof to derive Holing.
Yeah, but it is in term of number. So if you think in term of, then there will be a problem with the dimension. He didn't consider the biomass.
His assumption was number of species is equal to number of individuals.
Yeah, totally agree. But
J.R. Beddington also used the same kind of mechanistic approach to prove Beddington-De Angelis functional response also. But there are some ambiguities are there. Some people use biomass also and number of species also.
Yes, there is ambiguity. But you can think that, okay, my model, the Rosenberg-MacArthur model, one can think that I have used from chemical reaction and derive.
But we have to keep in our mind the basic assumptions, what Holing has made and J.R. Beddington has made. Then only I think then only that will be the proper model. Otherwise,
that will be proper. But you see, that when you are using Lotkov-Ultra, it is the mixture of both biological and chemical model. Then it is matching in either side. In the same way, Halling type Rosenberg-MacArthur model, it can, one may think that, okay, I have derived from the chemical reaction, one may think I have derived from the Halling. Then also it's the similar model. That way, without knowing people, they are using that it is the mass model. You understood my point?
Yes, sir.
That way they are using. And you can also see the Beddington De Angelis paper in theoretical population biology by Gillenberg, very recent paper, in 2 pages paper, how they have derived the mechanistic Beddington De Angelis functional response. They also use the number. It's a good question, and there should be more discussion. Of course, what you said, it's correct. There are some missing things.
Thank you, sir, for that interaction.
I think Dr. Darshan's volume is low. So since due to lack of time, we'll just take one question from Sudayashil Sarkar, and I think we'll stop the session, sir. Sudayashil Sarkar, am I right? There is a hand raise.
Hello, sir. Am I audible?
Yes.
Yes,
Please
yes.
be brief.
Yes. Sir, I have one question about the radical model logistic form. Is it dimensionally homogeneous?
I couldn't listen you question.
Yeah, voice was breaking. Can you repeat it once?
Sir, is the logistic model of the Ricard form, is it dimensionally homogeneous?
Couldn't listen, sorry.
Dimensionally homogeneous something. Okay.
Or can you write on the chat box? Someone can read it for me.
Yes, sir.
Vamsi sir, can you read it for me? Because
It's
I'm
there
not
in
very.
No, I also could not get, sir. I think connection was. Is logistic
Is
dimensionally homogeneous?
Logistic Ricard model.
Yes, sir.
There is no such Ricard model in continuous. Ricard model mostly used for discrete. So what is your point? I didn't understand. Mostly it is the discrete model, discrete time model, Ricard. All models should be dimensionally homogeneous. Whatever.
Otherwise, it is not a model.
I didn't see what was written in the chat box. How to read the chat box? Here I am
Just
not
press the
comfortable.
chat. It just says this, sir. Is the logistic Ricard model?
Is the dimensionally homogeneous? So you are talking about the discrete model, right? Discrete, because logistic, it is actually called the Ricard model. There is no such logistic Ricard model, to the best of my knowledge.
Yes,
If it is Ricard model, then it is dimensionally homogeneous. Actually, the population in Ricard model, it is in term of number. Okay, generally the sense is in term of number. Most of the discrete time models, it will be dimensionally homogeneous, definitely.
Okay, sir. Thank you.
So published paper is wrong in which not reserved dimensions. Oh, your question. You see, we should not say wrong. Our language should be different. There are some inconsistency in my opinion. Okay. Now, whatever the contribution done all paper, they have certain value in terms of their dynamics, computation, mathematics, their positivity, boundedness, Lyapunov stability, and many more. All paper are valuable. That's what we are further going. So papers are not wrong. I would say rather we say that those paper actually now the point that we have to modify things and we have to be more careful. Some information I have given, few of them may be more important to look for in the future. That's the only point from my side. Every model should be dimensionally homogeneous irrespective of the type of OD. Yeah, all model, 100% sure. Okay. And
okay, sir, there was a question. There was some members were requesting the presentation. Sir, can you share with me the presentation if possible? I can put it in the group.
Yes, you can. This presentation is not written very nicely. In the last 1 minute also I tried and many things I missed, but in the next 1-2 presentation, hopefully I will present somewhere such. This is the first time I am presenting, so it will be more improved. But at this moment, you can use for your personal things. Of course, I can, and I will be more than happy to share my paper as well. But I all the same time I request that also you use this paper for your future work. Even may not be for your fractional order system. In any system, it will be useful. But sometimes people may hesitate also that, okay, they have some different aspect. We don't want this one. And also, I think one should acknowledge in the same time, or even if you agree with the other things, then you write the other things that we are not. So this will be the better visibility. This time I personally like that you use this paper also. I request. Yeah, I'll share. Definitely I'll share.
Just to running short of time. So let's all thank, and sir's recording will be uploaded in YouTube. This lecture's recording will be uploaded in YouTube and shared with the participants. Before that, we will try to share the presentation as well as promised by Dr. Bapan Ghosh. Thank you, sir. So thank you for your wonderful and informative
thank you, sir. Thank you.
Detailed talk, I would say. So we will close the session due to we are running short of time.
Yeah.
So if there are any queries, kindly write to Dr. Bapan Ghosh, sir. So he will respond to his personal email ID. You can write whatever his email ID is. You can directly talk to sir.